Okay, well, we know the coordinates of this point, and the coordinate of this point is very easily determined because x and y are both 2. You plug that in, you find that z is 4. Okay? So we've already labeled these 2 points. I'm not going to bother labeling them here. I'm not going to bother labeling this one here, but when I draw it over here, I will. Okay? So what we have is we have 2 here and 2 here. And we come up this far to the point two, 2, 4. That's this point here. Okay? And then we come back to the point, what is it? X is 2, y is 9/2, z is 6, right?
Yes.
Okay? So 2 9/2, 6. Well, 9/2 is out about here. Let's see, here's 6, and here's 9/2, and out here is 6, and here is 9/2. Okay? So this point here, this point here, you know, I've got 2 x-axes. This is y here. Keep looking at it, thinking x. Okay? Misleading myself. Okay. At this point, x is 2, y is 9/2, z is 6, right? So 2 9/2, well, it's easy to get that. Right there is 2 9/2, right? And we come up 6 units. Okay, well, that's going to bring us up somewhat higher than 4. So we're going to be maybe here. Okay? And on this face, we'll assume that we've got a curve that maybe looks like this. Okay? Now that might end up hidden, so maybe I should have made it a dotted line and then filled in later, right? So I intentionally did that, of course, so I could demonstrate. It's probably not a good idea to draw solid curves until you're pretty sure you know what's hidden and what isn't, right? So I'm going to dot this. And then I'm going to draw the same curve out here. Because we got this point, we come up 6 units, and we've got a curve that kind of does this. Okay? And then we've got this curve, right? Which is just this one, our good friend that we've already seen. And that curve does this sort of thing, okay? Now it's a little hard to see exactly what that is, but it turns out that the way this is oriented, all these lines are visible. Just like we're looking at the underside of this sheet. The curve's back toward the origin because, of course, the origin's going to be one of our points. Okay? So we're looking at this sheet from underneath. And not sure how to shade this. Something like this. Okay? Again, we want to find the volume between here and the plane z equals 6. So let's just, for reference, get the z equals 6 plane back here. That's going to be, well, okay, there's part of it, and here's part of our cube. And this is below the cube, okay? So that this side is visible, and this side is visible. And now if the cube is solid, all these lines would be dotted. Okay? We don't want to do that because I really want to just think of that region. But there's a region between this shape and this one, okay? And that region only lies above the curve down here. This curve projects directly up to this curve, okay? And this shape here lies above this region in the XY plane, okay? So our surface I could write this as a surface 2 squared of xy, z less than or equal to 6. Okay? Because as soon as we get beyond here, curving upwards, z is no longer less than or equal to 6, right? It lies above this region. In the XY plane. Okay? So now we kind of have a picture like this. Here's our XY plane. Here's Z. So we have this region in the XY plane, okay? And up here, we project up 4 units, 4.5 units to this point and this point, 6 units up to this point, and we get this curve these points are at 6, this point is at 4. Okay? You get this region above. So this region here is in a plane parallel to the XZ plane. This region here is in a plane parallel to the XY plane. Okay? Just like you're looking at the back, you know, the plane x equals 2, the plane y equals 2. Sorry, y equals 2, x equals 2, okay? And then this curve lies directly above this. So it's probably going to get really messed up when I do this, but I'll do it anyway. So this curve here goes directly up to this one, okay? And might be a little hard to visualize, but we can work it out mathematically. That's not a great picture. Okay? Now, this region in the XY plane, how do you describe that region?
It would be the integral